Welcome to my video on equations as relations. So sometimes we must use a rule or equation and function table to find the range. So given the function y equals negative x plus 2 in the domain of negative 3, 0, 3, and 6, what is the range? So what we have to do here is we have to substitute each value of the domain in for the x value. So the first thing I'm going to do is put the domain in my table. And I'm going to use this middle space as my work. Now, not all tables that you make have this middle space, but usually they have an x and a y, and then sometimes they have a space to write the ordered pair. So my rule is negative x plus 2, or negative 1 times x plus 2. So what I'm going to do is substitute the negative 3 in. And if I'm substituting negative in, there's already a negative there, so I'm going to put the negative 3 in parentheses. And I'm going to add 2. Well, what's a negative times a negative? Okay, that would be a positive, so 3 plus 2. I'm going to draw an arrow over here, would be 5. So now I'm going to put those together and I get negative 3, 5. So the first range would be 5. Now I'm going to do the same for all the other values. So we have negative 0, plus 2. Well, negative 0, 0 is not negative or positive, so we'll just change it back to 0. So 0 plus 2 is 2. So we have the point 0, 2. And now we have 3 that we're plugging in. So there's already a negative there, so it's negative 3 plus 2. And negative 3 plus 2, of course, is negative 1. So write the ordered pair 3, negative 1. And when I write the ordered pair, I'm taking my domain and range and putting them together. And then finally, we have negative 6 plus 2, which is negative 4. So now, after I make a table, then I can just pick out the range from this column. And remember, we order from least to greatest. So the smallest number there is negative 4, followed by negative 1, 2, and then finally 5. And what these brackets are right here, it represents a set of numbers. So this is the set of the range for this function. Okay, let's look at example number 2. Now, this is a little bit different because my x and y are on the same side. Okay, so watch what happens here. So my domain is negative 4, negative 3, negative 2, negative 1. I want to know the range. And here's my function, 4x plus y equals 10. So the first thing I'm going to do is write my domain. And now when I plug it in, I'm going to have to solve an equation. So watch this, to solve for y. So I'm going to take out the x and put negative 4. And then I'm going to write plus y, and that's what I want to find, equals 10. So now I have to take care of this. And 4 times negative 4 is negative 16 plus y equals 10. And what I should do here, hopefully you didn't write that yet. Let's just move it over here. And we can say negative 16 plus y equals 10. And I'm only doing that because of the lack of space here. Okay, now we circle our variable and draw our t. What's the opposite of, or how do you cancel out 16 negatives? You need 16 positives. The 16s cancel, and what's 10 plus 16? 26. So the y value is 26. So now we combine the x and the y, so negative 4, 26. Okay, next one, we're going to plug in negative 3, and they're all going to be solved the same way. Plus y equals 10. Now, let's take these and figure it out. 4 times negative 3 is negative 12. plus y equals 10. And now I have to circle my variable and draw my t. How do you cancel out 12 negatives? 12 positives. And 10 plus 12 is 22. Okay, the next one is 4 times negative 2 plus y equals 10. 4 times negative 2 is negative 8 plus y equals 10. Once again, circle your variable, draw your t. How do I cancel out 8 negatives? Good, I need 8 positives. And 10 plus 8 is 18. And then finally, 4 times negative 1 plus y equals 10. 4 times negative 1 is negative 4 plus y equals 10. Circle your variable, draw your t. Whoops. That is if you actually draw the t and add 4 to both sides, and y will equal 14. Now, there's no way around it. When you, well, especially when you have a blank to show your work, you need to show your work. But when you make these tables on your own, there's no way to avoid doing work when you have the x and y on the same side. Okay, when you have y equals something, then you can just plug in the x and kind of do it in your head. But here, there's no real way around it. And because we have to show our work, we have a blank here, then we need to. Okay, now I'm going to write my y value or my range in order from least to greatest. So 14, 18, 22, and 26. Okay, turn the page. Okay, given the function y equals negative 3x plus 2 and the domain of negative 1, 1, 2, and 3, what is the range? Okay, so the range is negative 1, 1, 2, and 3. Okay, so now we're going to plug it in, and here's my rule. Negative 3 times x plus 2 will give me the y value. So we're going to do negative 3 times negative 1 plus 2. Order of operations will tell me to do this first, and negative 3 times negative 1 is 3, and 3 plus 2 is 5. So we have negative 1, 5. Okay, the next one, we have negative 3 times my x value of 1 plus 2. Negative 3 times 1 is negative 3 plus 2 is negative 1. Then negative 3 times 2 plus 2. Order of operations tells me to do negative 3 times 2, which is negative 6. Bring down the plus 2. And negative 6 plus 2 is negative 4. So we're going to write 2, negative 4. And then finally, negative 3 times 3 plus 2. Negative 3 times 3 is negative 9. Plus 2 is negative 7. Put them together and we get 3, negative 7. Now the range is all the y values, so I need to put them in order from least to greatest. So we have negative 7, negative 4, negative 1, and 5. Okay, now it says use the data from question number 3 to graph the ordered pairs. So I'm going to graph these ordered pairs, and I'm going to do x, then y. Okay, so the first one, and I know you can't see my table anymore, but the first one is negative 1, 5. So go over to negative 1, then right to 5. And then we have 1, -1, so over and down. And then 2, -4. And then 3, -7. Now, this particular function is called a linear function because it makes a graph of a line. So you can go ahead and get a ruler to connect your points or some sort of straight edge. And I want you to circle this point. We'll talk about this more in depth later. That is called the y-intercept, and that's where it crosses the y-axis. Okay, now the x value, this is the domain, and we call this the independent variable. And then our y value, remember this is the range, and this is called the dependent variable. And if you think back to our activity on skin weight, okay, our skin weight was the y value because our skin weight depended on our actual body weight. And remember, our skin weight was 1/16 of our actual body weight. Okay, so the skin weight depends on the body weight. So that would be my y value, and then my independent variable would be the actual body weight. Okay, let's look at the table. A function table uses a ruler equation to find the domain and range. So now we don't have a space for our work, so we can just kind of plug it in. So 4 times 2 is 8. I just took the x right here and plugged it in. 4 times 2 is 8. Now I have to work backwards. Okay, 4 times blank equals 12. 3. Now back to x, plug in 4. 4 times 4 is 16. And then now we got to go 4 times blank equals 20. So hopefully you were thinking 5. So put them in order from least to greatest, 2, 3, 4, and 5. Okay, our range, take your y values, 8, 12, 16, and 20. And that's it. Okay, go to the last page. Now, take a look here, and I may have to pause the video and restart here because our homeroom is about to start. Okay, given the function y equals -2x plus 6, fill out the table, then list the domain and range. So now I can just plug in the x. -2 times -3 is 6, and 6 plus 6 is 12. Now, working this backwards in my head when it's when you've got two terms in here is not very easy. So this I would encourage you to work out. So I'm going to show you how to do that. So take out the y and put 6. Okay, and we have -2x plus 6. Now the reason I didn't do this for the last one is because there was only one term there. Now, just like we did before, circle your variable and draw your t. The opposite of adding 6 is subtracting 6. And 6 minus 6 is 0. And the opposite of multiplication is division. So we're going to divide both sides by -2. 0 divided by -2 is 0. So my x value is 0 when the y is 6. Now I'm going to do this one over on this side because once again I have a y. So we're going to write 4 equals -2x plus 6. So circle your variable and draw your t. What's opposite of adding 6? Subtracting 6. 4 minus 6 is -2. Bring down your -2x. And now we got to solve for x. The opposite of multiplication is division. So the -2's will cancel. And -2 divided by -2 gives me an answer of 1. So x equals 1. Now, this last one, I have the x, so I can just plug it in. -2 times 5 is -10, plus 6 is -4. Okay, so now we have to write the domain. So the x is in order from least to greatest, -3, 0, 1, and 5. And now I'm going to write the y values in order from least to greatest, which is also known as the range. So -4, 4, 6, and 12. Okay, and now to our last and final problem. Given the function y equals x squared plus 1, fill out the table, then list the domain and range. So the first one, we have an x value, and we have our rule right here. So we're going to do -1 squared. And remember, that's -1 times -1, which is +1. And 1 plus 1 is 2. Now, this time I have a y value once again, and there's two terms here, so I got to work backwards. So I'm going to show you my work here. So circle your variable and draw your t. What's the opposite of adding 1? Subtracting 1. So the 1's cancel, and 1 minus 1 is 0, equals x squared. Now, what's the opposite of squaring something? Good, taking the square root. And the square root of 0 is just 0. Okay, now this is another x value, so just plug it in. 2 squared means 2 times 2, which is 4, and 4 plus 1 is 5. And then finally, our last one, the y value is 10, so we're going to plug it in. X squared plus 1. Circle your variable and draw your t. The opposite of adding 1 is subtracting 1. 10 minus 1 is 9, equals x squared. And remember from the previous problem, the opposite of squaring something is taking the square root. And the square root of 9 is 3. So put 3 here. And now we just have to list our domains in order from least to greatest. And then the same with my range, which is my y values from least to greatest. Okay, that concludes our notes on equations as relations. I hope you have a great day.